So today's topic is some basic concepts on geometry, and we will go through a couple of topics, and one of them is on angles. We'll look at the types of angles, and the second item that we will look at is the concept of the trapezoid. Okay? And we're going to learn something about the trapezoid that looks very, very interesting. Okay, then we'll take a look at that on the next slide. Okay, so we are going to take a look at angles. Okay, so angles, very simply put, is basically two segments, and the opening between them, we call that an angle. And so if we look at some of the angles, the most common one is the right angle, right? And the right angle means it's perpendicular. Perpendicular means this is 90 degrees, okay? So we call this a right angle, okay? And for the angles that open up and they are less than 90 degrees, right? So this angle here is less than 90 degrees. We call this an acute angle. All right? And for all the other angles that they open up to be more than 90 degrees, for example, in this case, this is greater than 90 degrees. And we call these the obtuse angle. Okay, so that is the basics on the three classification of angles. 90 degrees, right angle. Less than 90 degrees, an acute angle. More than 90 degrees, then we end up with the obtuse angle. Okay, and we're going to see how that relates back to the triangle on the next slide. Okay, so now let's relate what we just learned about an angle to a triangle. So if we draw a triangle, okay, and if this is a 90 degrees, we can call this a right triangle. Okay, and if we have a triangle that looks something like this, we know that this angle is definitely more than 90 degrees. Then I think we can call this an obtuse triangle. Why people actually spend all the time giving these triangle names, nobody knows, but we just kind of do it. Alright, and then if we have one of these triangles where all the angles are less than 90 degrees, okay, so pretend this thing is drawn such that it is less than 90 degrees, then we can call this an acute triangle. And one interesting fact about a triangle is that all the angles that they add up, right? All the angles means there are three corners, the three angles, the sum of the three angles, right? So we call this the summation sign. They're always equal to 180 degrees. Okay, example, if this angle is 90 degrees, then this angle 1 and this angle 2, the angle 1 plus angle 2 must equal to 90 degrees, because 90 plus 90 must equal to 180 degrees. And that ends the discussion for the triangle. Alright, and we will basically end the discussion, this basic discussion on geometry, with lines. Okay, so a line is basically a connection between 2 points. Okay, and it could go on forever. Okay, so pretend that these lines are drawn straight and they just keep on going. Okay, we say that two lines are perpendicular right if they touch each other, intersect, right? So line number 1, line number 2, and they intersect each other with a 90-degree angle, right? So 90 degrees. That makes these lines perpendicular. Okay. Now on the other hand, two lines are called parallel if they never touch each other. So for example, here is a line. Never means never, never, never. So here is one line, and here is another line. Okay, again, assume that these are drawn perfectly, so this is straight, and no matter how far you go out this way, no matter how far you go out this way, or this way, or this way, they never touch each other. And when that happens, we call these lines parallel lines. Okay, so again, perpendicular lines, they touch each other, and when they touch each other, we use a term called they intersect. Okay, and they intersect at 90 degrees. And then when they're parallel, that means they never intersect. Never intersect. Okay, so that ends this discussion on some simple concepts in geometry. Okay, well, to really finish, we really need to talk about trapezoid, because we kind of started saying we're going to talk about it. So trapezoid. So trapezoid is basically a shape that kind of looks like this, right? The top and the bottom parallel, they never intersect. Okay, so let's draw a trapezoid. Okay. So now the interesting thing is there's actually a formula we can compute the area of the trapezoid. So if this is L1 and that is L2, the area is equal to L1 plus L2 times the height. We'll call this part the height. Okay, call this part the height times the height divided by 2. Right, and if you don't believe yourself, or if you don't believe me, convince yourself. Alright, so let's say this trapezoid has an L1 is equal to 2. Okay, and L2 is equal to 4. Right, and this one, the area basically is L1 plus L2 times the height. And let's just say that the height is 3 divided by 2. In this area, it would give us 2 plus 4 is 6. 6 times 3 is 18. 18 divided by 2 is equal to 9. Alright, so do we believe that? Okay, so that's calculated. Okay, so let's draw the trapezoid. Okay, we said this L1 is 2. We said L2 is 4, right? The whole thing is 4. This is 2. This is 1. This is 1. And the height is 3. Now convince yourself that the area is indeed 9. So let's compute the area of the rectangle. The area of the rectangle here is 2 times 3, right? And 2 times 3 gives us the area of 6. And the area of this triangle and this triangle combined, we can think of it as the area of a rectangle, with this is the one of the length and this is the other one. And then that 1 times 3, right, twice becomes 3, right? So 6 plus 3 equal 9. Voila. The same as the formula.